So this is a TMUA question, which is actually an exam which you have to take if you want to get into Cambridge or Oxford University. So question says you have to evaluate this expression. What is this expression? This is summation n is equal to 0 till infinity sine of n pi plus pi by 3 whole divided by 2 raised to n. We have to evaluate this summation. So as soon as I see, what I see that this is an infinite addition that is happening. So an infinite GP or something else like an integration kind of should come into my head initially. What I will do is I'll expand a few terms and I'll see what is happening here. Okay. So this is summation n is equal to 0 till infinite sine of n pi plus pi by 3 by 2n. N pi plus pi by 3 divided by 2 raised to n. Okay. So the first term, if I put n as 0, if n is 0, this will become sine of n is 0. So 0 into pi is 0. So sine pi by 3 divided by 2 raised to 0 plus the next term, it's an infinite summation, is infinite. So this is equal to sine of, if I put n as 1, it is pi plus pi by 3, I'll write it like this only, divided by 2 raised to 1 plus sine of, if n is 2, it is 2 pi plus pi by 3 divided by 2 raised to 2. Okay. So sine of 2 pi plus pi by 3 whole raised to power 2 raised to 2. If I put n as 3, it will be sine of 3 pi plus pi by 3 divided by 2 raised to 3 and so on and so forth till infinite. It goes till infinite. Okay. So what is sine pi by 3? Sine pi by 3 is root 3 by 2. Sine pi by 3 is nothing but sine of 60 degree. Okay. And sine 60 degree is 0 under root 3 by 2. If you remember the value of sine 0 degree is 0. Sine 30 degree is half. Sine 45 degree 1 by root 2. Sine 60 degree under root 3 by 2 and sine 90 degree is 1. So sine pi by 3 is sine 60 degree, which is under root 3 by 2. Also, what is sine of pi plus pi by 3? So if I draw this quadrant here, first quadrant, second quadrant, third quadrant and fourth quadrant. Over here all sine, tan, cos. So all are positive here. Over here only sine and cosec are positive, which is 1 upon sine. Over here only tan and cot are positive, which is 1 upon cot is 1 upon tan. And over here only cos and sec, which is sec is 1 upon cos. They are positive. So this over here, this angle is pi. If I do pi plus pi by 3, that means I am going in this direction. Okay. And if it is 180 degree, which is pi plus pi by 3, this is nothing but minus sine of pi by 3. Okay. Which is minus root 3 by 2. So sine of pi plus pi by 3 is negative root 3 by 2. Okay. Similarly, if I have to do, let's say sine of 2 pi plus pi by 3. Sine of 2 pi by pi by 3 is like from here, I'll go 2 pi means I'm back at the origin from where I started it. And then again I add pi by 3. So add this pi by 3 here. Okay. So sine of 2 pi plus pi by 3 is nothing but sine pi by 3. Because all of them are positive, so it is positive. This pi plus pi by 3 was lying in the third quadrant. So that is why it is a negative, because only tan and cot are positive here. Okay. So sine of pi by 3 is root 3 by 2. So sine of 2 pi plus pi by 3 is root 3 by 2. Sine of pi by 3 is minus root 3 by 2. So it will repeat as, then 3 pi plus pi by 3 will be 2 pi here, 3 pi here, and then again 3 pi plus pi by 3 is in third quadrant. So it will again be minus root 3 by 2. So I'll get alternate positive root 3 by 2 and minus root 3 by 2 over here. So what I'll write is, this will be then equal to sine pi by 3, I'll write as root 3 by 2. Root 3 by 2 divided by 2 raised to 0 is 1. plus the next one is sine pi plus pi by 3 is minus root 3 by 2. So it is minus root 3 by 2 divided by 2 raised to 1 plus it will be then next will be further 2 pi plus pi by 3. It is positive root 3 by 2 square plus again then it will be minus root 3 by 2 cube and so on till infinite. This is what we have to find now. So I can take root 3 by 2 as common. So if I take this as common, this is 1 upon 1 which is 1 plus this becomes minus now minus 1 by 2. This becomes plus 1 by 4. 2 raised to 3 is 8. So it is minus here. So minus 1 by 8. Then plus 1 by 16. Then minus 1 by 32. And so on and so forth. Now over here, I see an infinite progression, geometric progression. So this is an infinite GP with common ratio is minus 1 by 2. Okay, because 1 into minus 1 by 2 is minus 1 by 2. Minus 1 by 2 into minus 1 by 2 is plus 1 by 4. Plus 1 by 4 into minus 1 by 2 is minus 1 by 8. Minus 1 by 2 into minus 1 by 2 into minus 1 by 8 is plus 1 by 16. So each term has a common ratio of minus 1 by 2. And the first term A is 1. Okay. If I know that if the sum of this kind of a GP, an infinite GP, sum of infinite GP is A upon 1 minus R. Okay. Where R, mod of R is lies between 1 and 0. Okay. So over here, sum of this infinite GP is 1 upon 1 minus 1 by 2, which is 1 plus 1 by 2, because R is minus 1 by 2. So this will be 1 divided by 3 by 2. 1 divided by 3 by 2 is nothing but 2 by 3. So this term in the bracket adds up and gives me 2 by 3. Okay, because this is a sum of infinite GP and applying the formula of A upon 1 minus R, we get 2 by 3 as the answer. So this will be nothing but then equal to root 3 by 2 into 2 by 3 into 2 by 3. So this 2 cancels, this root 3 upon 3, or you can say 1 upon root 3 is the final answer. So root 3 upon 3 is same as 1 by root 3. So what is the value of this? This is 1 upon root 3, and that is the right answer. Right? That's how you solve this Cambridge or Oxford level question. Thanks a lot for watching this video.